Good morning.
Yes, good morning.
Yes. Let's pray. Thank you, dear Lord, for the morning, for the one bless your name for this morning. Dear Lord, you have woken us up, mindful of this precious time. And we're going to learn, Lord. We pray that may you give us understanding, and we understand everything that our teacher is going to give us, Lord. Lord, we pray for wisdom upon our teacher, and may give him strength and courage, Lord, to continue teaching us, Almighty Father. Thank you. I pray this in Jesus' name. Pray. Amen.
Amen. Thank you so much for the word of prayer, Frank. Today we are going to continue with our second lesson on vectors. Yesterday, we basically looked at the introduction of vectors and we looked at how we obtain the magnitude of vectors. And we say that whenever we have a magnitude, let me say we have A and our A is X, Y, Z, we say that the magnitude of Z is always given, of A is always given by X squared plus Y squared plus Z squared. And then in case it is in 2 dimensions, then we say that one is always given by X squared, then plus Y squared. So that's basically what we looked at. And we say that whenever they may ask you to find the modulus, they may ask you to find the length, they can ask you to find things concerning distance. So whenever they ask that, indirectly they're asking you to find the length of those particular vectors. Now, today, our major area of concentration, we are going to look at what we call unit vectors, and then we are going to look at what we call displacement vectors. But once we finish this, then we shall be good to go. If I may ask in the chat, you can tell us, what do you understand when they say unit vectors? In the chat, you can tell me, when someone says unit, what comes to your mind when someone says unit? Or what is a unit? Any idea? Feel free to raise up your hand in case you have any idea. When someone says unit, do you have a unit? I think we have had people say so. In case maybe they want to communicate on phone and they ask, do you have any unit? Okay, okay. Now, when we talk about a unit in vectors will simply mean one. Now, when we talk about unit vectors, we are going to look at those vectors whose magnitude is 1. So for whatever vector you are going to deal with, and you find out that when you get its magnitude, you get an answer of 1, then that's what we call unit. Oh, sorry. Okay. Okay, so I was still saying that for whatever vector that you deal with and you find out that the magnitude you are obtaining is 1, then that vector is what we call a unity vector. And when we talk about unit vectors, so this is our area of concentration. Now, when we talk about unit vectors, the most important thing is for you to know that always your magnitude is going to give you 1. However, how do we represent a unit vector? A unit vector, we get a vector and then we put a hat. So this one we read it as a hat. So when they say A hat, they mean unit vector. In case it is D hat, it means still a unity vector. And what do unit vectors mean? Unit vectors indicate direction. They show us which direction is our vector taking. An example of a vector is like when you have force, when you have velocity, those are vectors. So which direction are they taking? That's what we call the purpose of a unity vector. So unit vectors, they always show us the direction that particular velocity vector is going to be taking. And by definition, when we talk about a unit vector, in order for you to get a unit vector, or for you to be able to get a unit vector, always, in case this is our direction, we shall always get that particular vector divided by its magnitude. The moment you do like this, it means that you are able to get a unity vector. So they can give you a vector and they ask you to transform it into a unity vector. So for you to be able to transform it into a unity vector, you get that vector divided by its magnitude. The moment you do so, it means that the magnitude of that vector that you are going to get is going to be 1. But like I've told you that a unit vector shows us the direction that we are facing. A unit vector will indicate that this particular vector is taking this direction, whether it is going like this, whether it is going like this, whether it is going like that. So its purpose is to show us which direction is my vector taking. So in this particular aspect of unit vector, we are going to look at scenarios whereby they have given you the magnitude, they have given you the direction, and they want you to find the velocity that gives us that direction and gives us that magnitude. So by doing so, we shall use the knowledge of unity vectors. So may I ask you now to summarize something, and let me hope we are still on the same page. You can let me know through the chat whether we are still on the same page and whether we are good to go. But I want you to summarize the definition of a unity vector. That vector divided by its magnitude. When you are done, you let us know and then we can continue. Okay, same page. Okay. People saying, I think, okay. Yeah. Okay. So I think we can move on and try our first number here. So when you look here, they have given us the first activity. They are telling us that find the unit vector in the direction of the vector this. So they have given us our vector. Our vector is A equaling to 2I plus the 3j. So we have said that by definition, to get a unit vector, it means that we shall come and say a unit vector, we denote it by A hat, is given by the vector divided by its magnitude. That means that the first thing you are going to obtain is obtain the magnitude. So we are going to obtain the magnitude of A. And yesterday we said that the magnitude is always given by the x component plus the y component squared. And when you look at the vector that has been given us, you notice that we say that the I component has the x value, which is 2. Then the j component here has the y component, which is 3. So that means we are going to come here and say this is 2 squared plus the 3 squared. And this one will end us giving us 4 plus the 9. So when you have the 4 plus 9, you end up with root of 13. Now, for such a case, since we want to get our magnitude as 1, if you get a square root that you cannot reduce, please carry it on. Carry it on. So that means we shall say A hat is equal to our A divided by our magnitude, which is root of 13. But what is our A? Our A is 2I plus 3j, everything divided by root of 13. So what are you going to do? You can now separate and say this is 2 out of root 13I. then plus 3 out of root 13j. And now this is what we call the velocity vector. So this is what we call our unity vector. Are we on the same page, members? Are we still together there? Okay. 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 That is good. Okay. Oh, did I saying, aren't we supposed to rationalize? Even if you rationalize, you get the same thing. There is no problem. If you want, you can rationalize, but that one is also enough. Okay, Shadik, I have said, okay, let me first give people here a number to try for me. Find the unit vector. Uh, oh, okay, let's see something. Okay, I have this given C equals to 8, 1, and 4. Find C hat. So let everyone be trying out. So Shadik, we have said that when they tell us to find a unit vector, what you do always, get that particular vector they have given you, divide by its magnitude. So I expect you to get this vector, you divide it by its magnitude. So to get the magnitude of the vector, we said you get just the square root of x squared plus the y squared. In case it has three components, then plus the z squared. But we say that in vectors, when we have ai, bj plus ck, what is in the position of a represents the x component. What is in the position of j represents the y component. What is in the position of C represents the Z component. In case it is given in this column form, then the first one is always your X, the second one is your Y, and then the third one is your Z. So you extract them from the column vector, and then you substitute them here to be able to get. Yeah. And always this answer you get, when you go back and you try to get its magnitude, you are going to find out that the answer is 1. What about getting the square root of 13? Yes, the square root of 13, is like a decimal points. So mean that when you write in decimal points, your final answer will not give you a magnitude of 1. So that's why we maintain root of 13. Because when you try to place your calculator and say, let me give the answer of root of 13, you'll get 3.6055 like that. So at the end of the day, when you try to get the square root of the unit vector you have obtained, then it means that you are not going to be able to get your magnitude as 1. Then does the unit vector has its units? No. A unit vector will not have units. Does not have units. Then, so velocity vectors are the same as unit vectors? No, they are not. A unit vector is the direction. Unit vector is the direction a particular vector is taking. Then when we talk about velocity vector contains a magnitude and contains the direction. Faizo. So a velocity vector, like the velocity vector, for it has the magnitude and has the direction. A unit vector only contains the direction. That is the difference between the two. Okay. From the chart, the answers I'm seeing are correct, members. The answers I'm seeing, Martina, that is correct. Frank, that is correct. Toshiba, that is okay. Allison, that's fine. Cab, that's okay. Hans, that's okay. Joyce, that is okay. Benjamin, that is okay. Yes. Yeah. The answers I'm seeing in the chat. Ray, that's okay. Dilla, yeah. So the answers are okay. The answers are okay. Aha, yes. Now, in case for Mercy, that's okay. Imran, that's okay. Yeah. For cases whereby when you get the magnitude, when you get the square root, you can get a perfect number. For such cases, go on and get a case in point for this particular one you are doing. You notice that its square root is possible. So that one, please you go on because you had 8 squared plus 1 squared plus 4 squared and you ended up with root of 81. So for cases where you can get a perfect root, for those ones, go on and get the answer. So here, I expect you to get 9. So that is very okay. Go on with it. Then to get the unit vector, I expect you now to divide this column vector, divide by 9. So in case you are not getting the answers we have in the chart, then you have to check out where the problem is. Yes, the answer stops there, Sajabi. Do you maintain the addition sign? Yeah, when you write it in this form, 8 out of 9i plus 1, okay, plus j out of 9, then plus 4 out of 9k, this is very okay. But also I want you always now, you need to read the question. In case the question they gave you in a column form, then your best answer would also be when it is in the column form. So here when you are writing your final answer, it will look much better, or it is very okay when you write 8 out of 9, 1 out of 9, and 4 out of 9. Because your answer was given in a column form, so when you are giving your final answer, it is very fine for you to give it in this form. This is the most recommended, so such that you maintain the flow of the item. Okay. If you want, someone else could write it like 1 out of 9 into 8, 1, and 4. Still, that is very okay. Aha. In case it can be divided, that is very okay. Go on and divide. Because you may find that there are numbers that can be divided, you go on and reduce them. It is okay. Yeah. Okay. Hope Joyce, that is okay. You can divide in case it can be reduced. Okay. Now we are going to enter into the application. Where do we apply these unit vectors? Okay, Imran, come in.
Excuse me, sir.
Yes.
I'm inquiring about putting the heart sign on this I and J because we were told at school that we're supposed to put them.
It is okay. It is very okay to put the heart because it
Yeah.
represents the unit vector. I, J, and K represents the unity vector. So it is very okay for you to have them there.
Thanks.
Okay. Now, where do we apply them? We are going to meet scenarios, examples of vectors we have force. We have things like velocity. Now, I want you now to remember some of the physics you learned. Velocity and speed are related. Distance and displacement are related. Now, they are going to come up with a scenario whereby they have given you the speed and they have given you the direction. But they are interested in you finding the velocity. So when you read the question and they have given you the speed and they have given you the direction, for you to be able to get the velocity here, you need to remember that to get velocity vector or to get the velocity vector, you know that to get velocity vector, you know that the unit vector, this is v, v is the unit vector. We know that it is given by the velocity v divided by its magnitude. Hope this is okay. That in case I want to get the unit vector of this velocity, I'll get the unit vector of the velocity is equal to v out of its magnitude. So now, what is the question interested in? The question is interested in you finding this velocity vector. So for you to be able to get this velocity, you are going to cross multiply. So when you cross multiply, you'll end up with the magnitude of the velocity times its unity direction vector. Members, first let me know whether this is okay, what I've written there, whether you have understood that step. Joyce has said yes. Linda say yes. Okay, good. Okay, that is okay. So whenever this magnitude of V is what they are going to term as speed, because you know that whenever you obtain the magnitude of velocity, what you get is the size, and that is what you have as speed. Then V is what we call the unit direction vector. So when the question is going to give you, they are going to give you the direction of a particular vector. So for you to be able to get the velocity, it means that you are going to get the magnitude, which is, for this case, in case it is speed, it will be speed times the unit direction vector. In case it is in terms of force, they will tell you that a force of magnitude may be 8 newtons in the direction of this, and they ask you find a force. So they are asking you find for us. So that means you need to know that the direction vector of force is given by the force divided by its magnitude. So for you to be able to get this force, you cross multiply. So your force will always be the magnitude times the unit direction vector. That means that you'll get the magnitude of the force that has been given to you times the unit direction vector. So that one you need to be in the know of what you are going to do. So let me first place the first item. Techno, you may ask. This is our first item. You can go through, and I'm going to ask you to first apply what I've told you to see whether we can get the answer. In case you get the answer, first drop it in the chat before we try it together. Yes, Techno. Yes, Techno? Okay. I'm not getting you. Okay. So I want you to summarize. Always read it through. They're telling that a boat moves with a speed in a direction represented by this. Find the vector representing its motion. Now, the vector representing its motion, because they have given you speed, you need to know, for speed is the scalar. The vector is the velocity. So indirectly, they're asking you for the velocity. So I want you to first try out, and then I check. Okay, I think I first do for you one. So here, they have given us the speed, and the speed has been given as 49 kilometers per hour. They have given us the direction that we are taking, and our direction has been given as 3I plus 6J plus 2K. What does it mean? Like I've told you that the unit direction, let me say V, is always given by the velocity vector divided by its magnitude. So in order for us to get the vector, it means that I'll get the magnitude of V times its unit direction vector. Now, here we have the direction, but we don't have its unit direction vector. So the first thing we are going to find is the unit direction vector. So I'm going to come here. I can represent it by D. So I'm going to first find D hat. So D hat is given by the D divided by its magnitude. So D hat is going to be our D, which is 3I plus 6J plus 2K. Divide everything by the magnitude. For this case, is going to be 3 squared plus 6 squared plus the 2 squared. So this will give us 3I plus 6J plus 2K. Divide by 3 squared plus 6 squared plus 2 squared. When you do the mathematics, I think this is 9 plus 36 plus 4. I think this is what, 49? Something like that. So 6J plus 2K, everything divided by, is it 49, 49, 49? I think this is 49. And therefore you end up with 3I plus 6J plus 2K. and the square root of 49 is 7. Now, this is the unit direction vector. Now, after obtaining the unit direction vector, your work is now to come back here and say now to get the velocity vector, I'll get the magnitude times the direction. So that means that your V is equal to the magnitude of V times the direction vector or the unit direction vector. Remember I told that unit direction means the direction which this boat is going to take. Which direction is the boat taking? That is the meaning of a unit direction vector. I told that the unit direction vector, it gives you the direction a particular object is taking. So in order for us to find it in a velocity form, it means that get the magnitude, multiply it times the direction vector. So for this case now, we shall say this is 49. I multiply it times our unit direction, which is 3i plus 6j plus 2k. Then everything divided by 7. So when you continue, say by 7, 1, by 7, 7. So I remain with 7 into 3i plus 6j plus 2k. And then yesterday we looked at how we deal with a scalar. So we multiply it inside. 7 times 3, we end up with 21i plus 7 times 6, that is 42j. 7 times 2, that is 14k. Now, this is our vector for the motion of the boat. Then we go on and put units that since this is velocity, it is in kilometers per hour. So we shall say that now our vector is going to be 21i plus 42j plus 14k, and then everything is going to be kilometer per hour. And that is the answer. Kindly let me know through the chat whether we are on the same page, whether we have understood or not. Okay, Percy, that was correct. People are saying we are on the same page. Very good. Master Judith, you can put your hand up. You can put your hand up, and I see. And even to prove your answer, if you want to prove your answer, this answer we have got, when you go on and find its magnitude, you must come up with 49. That is one way to prove that what actually you are doing takes back. Yes, Mercy.
Good morning, sir.
Yes, good morning.
I'm lost from the continuation where we were starting to get the velocity vector.
From where? Here?
Yes.
Okay. Did you understand how we came up with this?
Yes.
This formula?
Yes.
Now, when we reach that point, this root of v times the direction, this one is the magnitude. And when we are dealing with velocity, its magnitude is the speed. And when you look at the question, they had given us the speed, the magnitude as 49. So where you have this is where you place 49. Then times the unit direction vector that you have obtained. And for our case here, we had obtained the 3i plus 6j plus 2k out of 7. But since this is multiplication, this 7 can reduce with the 49 here. And you say 49, you get 7. Alternatively, if you had entered this 7 inside and you had done 3i out of 7 plus 6 out of 7j plus 2 out of 7k. Now, if you are multiplying with the 49, enter the 49 and say 49 times 3 out of 7i plus 49 out of 7 times 6, then plus 2 out of 7 times 49k. Then you can reduce still by 7, 1 by 7, 7. Then 7 times 3, you get the answer. Is it fine? Hope, Judith, that one is okay. Okay, Brian?
Yes, it is now fine.
Okay. Brian? Mlawa Brian? Okay. Okay. Maybe Brian, you can type in the chat. Okay. Now, that is one way they can set it. Another way they can set it, they can give it to you in this form. That first item I've given you, they can give it in this form. It is the same item. So they can say a boat is lowered with a speed of this in the direction of this. Determine the true velocity. Now, the moment you read the word true velocity, don't be confused. In other words, they're asking you the velocity form. So it is the same item, but now the setting can change. So because now you need to know that speed is related to the velocity. So when they say true velocity, you do the same thing, the same answer. In other words, this question, the other first question, they are the same, but just the setting and the wording may change. Okay. I can go to another one. Why don't you try for me this one now on your own? Let everyone try out this and you post your answer in the chat. Okay, I'm going to look through the chat. Oh, hey, Brian, I think kindly check out. I think you had an error on the square root. Maybe you didn't add well because when you have 3 squared plus 6 squared plus 2 squared, 3 squared is 9. Then plus was I think that was it the one? Hmm. 9, then 6 squared is 36 plus 4. So when you add everything here, 9 plus 36 plus 4 gives us 49 instead of 47. So I think check out on that addition. Okay. From the chat, I'm seeing Percy, Tumwine, Cab, Gilbert, Rita, Joyce. Okay. I'm seeing some answers coming out. Yes. Martina, you can unmute. You can take us through what you have done.
Teacher, I'm almost, I'm finalizing. You give me like 2 minutes.
Okay. Okay, Ezekiel, Shiba. Okay, I'm seeing some answers. Robert. Okay, someone saying it's not coming out. Rebecca. Guest. Those who are finding Gilbert, you check out how you dealt with those negatives. Someone is lost. Okay. Yes, Genesis.
Master, what I'm asking, since here we are not given the SI unit, can I just put units or I don't put anything?
You don't put anything, you can just leave it there.
Okay, sir. Thank you.
Okay. Why we don't commit ourselves to any units? Because we are not sure which velocity it was, whether it was force, whether it was what. Yeah. Yeah. Husna, I've not seen your answer. Mary, I've not seen. Alison, I've not yet seen your answer. Okay.
I'm ready to take us through now.
Okay. We can start.
Okay, so the first thing that I did was to identify what the question has given me. So they have not given me vector, but they have given me the, okay, I don't call it speed, but the magnitude, which is 15. And then the first thing I had to do was to find the, they call it the direction, the unit direction, something like that, using the 2i, negative j, negative 2k.
Okay.
So I said the v hat is equal to the vector divided by the magnitude of the vector. Then I said v hat is equal to 2i minus j minus 2k out of square root of 2 squared plus negative 1 squared plus negative 2 squared. Then when you work that out, you get v hat is equal to 2i minus j minus 2k all out of root of 9. Then once I got that, that's now like my v hat, so I now have it. Then I said vector is equal to the magnitude of the velocity times the unit direction. Yeah. So I got v is equal to, v which is the vector, is equal to 15 times what we got as the unit direction, which is 2i minus j minus 2k out of root of 9. Then when I tried dividing 15 by root of 9, I got 5. So it became v is equal to 5, open brackets, 2i minus j minus 2k. Then my final answer was v is equal to 10i minus 5j minus 10k.
Okay. Thank you, Martina. That is correct. Okay. I don't know whether, Martina, you noticed that root of 9 can be obtained. Yes. So this is very okay. And this is how I expect you. So, but one thing I think you need to notice is that for some roots, whenever you can get a perfect root, go on and obtain that root. A case in point, root of 9, you could obtain it as 3. So that one can be very okay. But some of you who have those standard calculators, it can as well simplify it for you. Okay. Then 2, whenever they have not specified, feel free to label or to name it the way you want. You can say, let my direction vector be d, and then you say d is equal to 2j minus j minus 2k. So you can let it depending on what you want. Okay. Ruth and Imran.
Good morning.
Yes,
So
morning.
my question is,
Mm.
should I just take it that the magnitude that is given to me in the question is used this side? Well, can I say it? Because we're having to, at the end of our working, we end up seeing that we have two what? We have two magnitudes. So should I just take it that I first work out, I get the magnitude using the vector given to me, then I use the magnitude given in the question to get the answer. Like I just take it like that, or there's an implication that it can, whatever.
Okay. At the end of the day, the first thing, Ruth, we have to do is they have given us like the size of the force. Let me call this like to be like force. They have given you the size of the force, but they have not told you where it is going, whether it is going to east, west, north, or where. Now, you finding the unit direction vector, it helps you to know the actual direction where it is going. Are you getting it?
Yes.
So this first part we do is to find out which direction is our force facing. Is it going this side? Is it going this side, like that? So at the end of the day, when you get this magnitude of the force times its direction, that's when you can get it in a vector form.
Okay. Thank you, teacher.
So always, but what you are saying, it is okay. You get this magnitude times the unit direction, times the unit direction. Not the direction itself, but times the unit direction vector.
Okay.
Okay. Imran? Now, those who had, yes, Techno, you may ask, those who had challenges, the challenges came from here. When you are getting the square root, some of you did like this. This is where the mistake came from. So you ended up getting 4. Here, I think you may have put 1, -1, and here you put 4. Here, that's where the mistake was. Because when you square a negative, you get a positive. Square a negative, you get a positive. So the mistake came from those brackets inside, for those who were not getting it. Yes, Techno?
Sir, I'm asking,
Mm.
what units are we putting on this answer?
Now here, since they did not give us units, we cannot put any unit. We just leave it there.
Okay.
Okay.
Thank you,
Only
sir.
commit yourself to units if they have put them there. If they have not, it is okay to leave it. Now, that same item, this same item I've given you, can be set in this format. Hope you are seeing, members. So that item I've given you, it is this item now. So here I have been able to specify for you that it is force of magnitude this. Find in vector form the force. So your answer still remain the same. But here, since I committed and I told you it is newtons, so that means that the final answer you get, you put the newtons. So I'm just showing you how now it can, like the different ways it can be set. So in case you find force, just remember that force is a vector quantity. So that is how you deal with. But at the end of the day, the answer you get, go on and find out whether its square root gives you the magnitude that was given to us. Okay. We can continue. I think this one, you can just take a screenshot. You try it in your free time. Okay. Hope you have finished. To take a screenshot. You'll try it in your free time. Now, we are going to look at how do we find the vectors between 2 or 3 points. That's what we are going to look at. Now, when we are finding the vector between 2 or 3 points, one thing we need to pay attention to is the direction of these particular vectors. Where possible, go on and make a simple sketch because direction is going to be very important. Take an example. Say, in case this is our vector diagram, I have this as A, I have this as B, and I have this as C. In case this is AB and this is, let me say B and C. In case I want class, I want to get SC, put for me in the chat, how are you going to move from A to C? Put in the chat. What would be your direction? How are you going to move? I want you to tell me, I'll move like this up to this. Put for me those two letters, how you are going to move. Just place in the chat, I want to get A to C. How are you going to move? Gilbert, A, B, B, C, A, B, Okay, perfect, very good. That is very okay. And I want you to take note, always, whenever you are doing, you need to look ahead. When you notice, we say that A shows you the starting point, where you must start, and please always start from there. Then the second one shows you the final point. The question is indirectly asking us, how can we move from A to C without... So it means that I'm going to come from A, I go to B, then I add on. From B, I continue to where I have my C. And what are you noticing? That your starting letter here was A, which is here. And the ending point here is your C. So you are going to look out for that kind of relation. And you are going to notice that these two here, they may have some kind of connection. Now, this is the type of mathematics now we are going to look at. They may give you 2 points, they may give you 3 points, but now you must come up with the final vector. So we start on the first one. So I'm going to ask you, this is our first item I want us to look at. They have given us the vectors. Like we said, whenever they give us 2 letters, it means they have given us the displacement vector, as long as you don't have an O. So they have told us that vector PQ is this, QR is this. Find the vector PR and QP. What do you need to look? Whenever you get these numbers, ask yourself, how many letters do you have? That I have P, I have Q, and I have R. Now, if you find yourself that you have 3 letters, it is very okay for you now to know that which figure has 3 sides, that is a triangle. So that means you can come up with a good triangle and label it very well. That let one of your sides be P, let another one be Q, and let the other be R. In case you find that the letters are 4, then you know that that is a quadrilateral. So that means that your sketch, let it resemble a quadrilateral such that you know how you are going to move. So now you notice the first one, they gave you P to Q. So I will say this is how the direction is going to look like. The next one, they gave you Q to R. This is how the direction is going to look like. Then they want you to find P to R. So that means that if they want us to find P to R, members in the chat, which directions shall we use? Now, Jordan, what you have given may not be true because that one only applies when you are looking at position vectors. Bring in the O and the what when we are looking at position vectors. Mercy, Sharon, Angelic, Hans, that is okay. Gilbert, that's okay. Sharon, that's okay. Cab, that is okay. Dorcas, yes. Joseph, yes. Your answers in the chat are very okay. So that means that to get from P to R, I'm going to move from P to Q plus Q to R. That's what I'm going to do. So you get, they have given us a vector P to Q. So I will come here and I say, this is 3, -5 plus my Q to R, which is 4, 1. And we say that in vectors, when we are adding, we add the X and the X, Y and Y. So that means we shall have 3 plus 4, and then we shall have -5 plus 1. Then at the end of the day, we shall end up with 4 plus 3, which is 7, and then we shall have our -4. So that is our vector P to R. So that's how we get it. In case we have Q to P, members, can you get Q to P? You can put your answer in the chat. Put your final answer for Q and P. Yeah, all those answers, Susie, Steve, Tekino, Jerry, those answers. IMO, Patrick, yeah, Ken, Galax, yeah, those answers, okay. Oh. Okay. Alison, which answer do you have for Q to P?
Now I have -3, 5.
-3 and 5. Can you briefly tell us how you have obtained it?
I drew the triangle. Then I had QR.
Okay, Q to P, you said QR.
Plus RP.
Okay.
Then we have QR 4, 1. And then for RP,
Then for RP?
since I'm going to a different direction, the signs change.
Okay.
Yeah. Leaving us with -3.
Oh, okay. Which sign did you put here? That's what you have not told us.
Where?
Here.
Oh,
Are
I
you seeing
put
what I'm...
minus.
Minus, Okay.
Yeah.
Okay.
Yeah.
So you ended up with?
-3, 5.
Okay. Thank you, Alison. That's okay. Another approach, Chiza.
Excuse me, teacher.
Yes.
I think when we are asked of QP, we just interchange the signs because after finding, just change the signs of PQ.
So what is QP? It is the same as?
PQ, but interchanging the signs because we are changing the direction.
Okay, good. That is very okay. So QP can as well be the same as -PQ. Or someone can put -1 PQ, such that you come here and say this is negative of 3 and -5, which will give you 3 as -3 and 5. So whatever approach you use is okay. So Alison's approach is okay. This approach is very, very okay.
Thank you.
Okay, thank you. Okay, so that's how you approach search. Okay, members, are we good to continue? Are we still on the same page? Are we okay to continue? Okay. Gilbert says yes. Majida? Oh, okay. 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 Can you try for me that? Can you get for me? Just get for me these two, and then we continue. Get for me those two quickly, and then we can continue. Majida? Okay. Majid, I'm failing to get you. Okay, quickly get only for part 1 and then we continue. Okay. Okay, good answers are coming in. Answers are coming in. IMO, you have said you have a question.
Yes, good morning, sir.
Yes. Yes, good morning.
So on the previous screen,
Hmm.
what if I just interchange the signs of vector RP? For example, -7 and 4. Can't that work
When you are finding what?
when I'm finding vector of QR?
QR. And you say it is the
When
same
I'm
as?
finding the vector of RP.
When in the question you have?
For example, the last number will
Or the last part, eh? It is okay, you can just interchange. As long as you multiply by negative, eh? Because in vectors, your RP is the same as the negative PR. As long as you have that relation, it is okay. Fine? Okay, okay. Okay, I'm happy some people have gone on even to part B. Okay, good. Eh, okay, yeah. Okay, I think this is a bit okay. I think let me now put some scenario and then we test out. Hmm. I think we can also first try out this. We can first try out this. May I will come in after seeing all your answers. But the answers 0, 6 and 0, -6 are very fine, members. Okay, so we are doing this one on the screen. So I expect you to first find for me part A, place your answer in the chat. Feel free even to do all the parts such that we can go through together at once. Okay, I'm looking through the chat to check out the answers. Uh, oh, wow, wow, wow. Good, good, good. Yeah, I'm saying the answers are very okay. Yusuf, check out. Joseph, that's okay. Frank, that's okay. Joyce, that's okay. Patience, okay. Gilbert, okay. Tumwine, okay. Ocean, Percy, Imran, Alison, Hans, Toshiba. Oh, Mary, Mary Lynn, we have said, when you find three letters, the first thing you do is first come up with a vector diagram. And when there are three letters, you look out for a figure that has three sides. An example, you may look out for a triangular figure. Name it A, B, and C. But we are going to help you. Susie, Steve, yeah, Gilbert, yeah, Judith, Itel, Abud, Rebecca, Brian, Joseph, uh, Jeren, O'Shane, yeah, Alson. Yeah, I'm saying the answer. Martina, Joshua, Angelica, Rebecca, yeah, Nesag, yes, 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 yeah. I'm saying all the answers are okay. The answers are okay. The answers are very okay. I'm going to hope just on part B. Yes, yes. Well done, members. This is okay. It is only okay. Who wants to take us to number part A? Someone to take us through part A such that we have also those members who are not yet there on board. Okay, yes, Toshiba.
Part A. Good
Okay,
morning.
morning.
Like they are telling us to find the vector SC.
Mm.
In the first position, you have to sketch out
Okay.
our triangle. And then run from to find SC, you have to run from A to B and B to C. Whereby they gave us our A to B, it's 75, 90. Then we add negative 35, 100. Then the next step, we form a one vector which is 75 minus 35, and then 90 minus 100. Then we get 40, and then 10. That's the vector SC.
Okay. Units?
Units, kilometers.
Kilometers, okay. Uh-huh.
Yes.
Oh, okay, thank you. Anyone who wants to tell us something about part B? The aircraft then flies directly back to A. Write down the vector that describes this flight. Yes, Genesis?
Sir, part B, they said that the aircraft then flies directly back to A. It means it is from C to A.
C to A,
So
good.
C to A is equal to the negative direction of SC. So negative SC, which is negative into 40, negative 10, which is
Okay.
negative 40, 10 as the answer, kilometer.
Okay, kilometers. Okay, this is very fine. So that is the vector. In case, now for this one, someone who wants, in case they told us even to describe, then you would, the best description, write down the vector that describes this freight. In case you are describing the freight using the vectors, remember X and Y. And we say that if someone is moving, this is your west and this is the east. This is the north and this is south. We say that when you see a negative on X, it means someone is moving in the west. So here, someone can describe it as the flight is 40 kilometers towards the west and 10 kilometers in the north direction. So that's how you can describe it. You say 40 kilometers towards the west and 10 kilometers in the north direction. Okay. Then the last part, calculate the direct distance from C to A. Oh, I had seen Linda. Okay. Imran?
Calculate the direct distance from C to A, meaning we are going to use the vector we've gotten in part B, and we are going to get its magnitude.
Okay.
So we write it as, we can put the formula as x squared, root of x squared plus y squared. And we note that our x is negative 40 squared plus 10 squared. And that gives us root of 1,700. So we can either leave it like that or write the answer as 41.23 kilometers.
Now, in decimals, make sure you write to at least 4 decimal places.
2311
kilometers.
meters.
Yeah. Okay. That is okay. Thank you. Hope everyone. Okay. Okay. Hope now it is clear to everyone. Distance is the magnitude. So let it not confuse you. Even if they had mentioned length, still it is the same thing. Yes, Joan? Oh, sorry. Joan, come again.
Excuse me, sir.
Yes.
For me, I just need more clarification about that number C.
Like, Joan, is this the first lesson? Oh,
Share the second.
the second. Okay. Yesterday we looked, Joan, at how we find the modulus or the length. Do you remember?
No.
Oh, okay. Like, oh, I think this is your first on vectors. What is, because yesterday we looked at it. Like we said, when you look at this CA, we have obtained CA as negative 40 and 10. In vectors, the first one is your X and this is your Y. So in case I'm trying to plot this, it means that 40 being negative is going to be somewhere here along the x-axis. Then 10 is going to be here. What does it mean? It means that that point is a point here from the origin like this. Now, what the question is asking us that, what is this distance from here up to here? Now, in order for us to be able to do it, we are going to come here and draw a triangle like this, like this. Now, vertically here, you have 10. Here, you have 40 as your distance. So in order for you to be able to get this hypotenuse here, we apply the knowledge of Pythagoras theorem, that this is like your A and this is your B. But you note that A is lying along the x-axis and the B lies along the y-axis. So for you to be able to get this C you want, you say C squared is equal to a squared plus b squared. But your a squared is the x squared, then b squared is the y squared, and a c squared is the distance they want. So in order for you to be able to get a square root, get a square root. So that's where the gentleman is getting this formula from. So from your item here, for you extract the negative 40. But here, when you are placing it, put negative 40 squared, then plus 10 squared. Now, the calculator, the moment you don't put these brackets, it's going to give you a wrong answer. So always put a bracket because the calculator cannot square negative 40. So for you, what you do, make sure you put a bracket or mathematically know it that whenever I have negative 40 squared means negative 40 times negative 40. So negative 40 squared, you'll end up getting 40 times 40, which is 1600. And then 10 squared is 100. And that's how the gentleman came up with 1700. I don't know whether it is okay. Okay. Let me remove this screen and I give you another one. We have another scenario there. Paizo, Naomi. Hey, Naomi, yes, you pay attention to the number of decimal places. Okay. Okay, Angelic, let me hope it is clear on part B. Okay, Martina, Addison, Toshiba. Mm. Oh, how to describe the direction? We said you can say the flight is 40 kilometers towards the west and 10 kilometers in the north direction. Okay, Toshiba, what you are saying, I think it is okay. That some features were changed. Okay, thank you. I'm seeing some answers coming in from Mercy Judith, from Patience, Percy Judith, Marine. Okay. Yeah. So remember, for these particular ones, you having a sketch can support you a lot. Having that visual diagram on how does this thing look like? How does it look like? I think now everyone has cracked the code. To Tumine, Helen, Martina, Hans, Alison. Hope Alison, this is for part B. Okay. In case, let me just show you in case you were to draw it, how it can look like. You know those people who are doing land surveying, whenever you are going to demarcate an area, you're going to make measurements in the area, you keep on putting like flags, like small poles at each corner, at each point like that. So now the first one is 5i. Now, mathematically, you know, 5i, you remove along the x-axis, then you move up. So, this is just a rough thing. I'm just putting for you here, just for understanding purposes. 3, 4, 5, 6, 7, 8, 9. But there's no need for you to do this. So it means someone will remove 5. This is 5 and 1. Let me say this is 1, 2, 3, 4, 5, 6, 7. So 5 and 1. We'll move like 5 and then 1. Sorry. This is the 5 and 1. So it will be like here. So that will be, someone would have moved here. So the first flag is going to be here. This is where he's going to place the first flag. Then from there, he moves negative to negative 2. It means like as if someone is moving backwards. So you move 2 steps backwards. So I'll move 1, 2 up to here. Then I move 4 up. 1, 2, 3, 4. So then it will come like this, something like that. Then from there, he moves 4 in the positive. So he moves 1, 2, 3, 4, and then he moves 2 up. So 2 up, he will be somewhere here, something like this. Then 6, then he moves like this, then he moves up. So your thing will be something like that, whereby you have the flag here, you have an, so you have a flag here, a flag here, a flag here, like that. So the question is asking, find his displacement vector from his starting position when he puts out the last flag. So in other words, they're asking you to have everything here. So what I expect you to do is that you're going to add up everything you have here. So you add everything you have here and then you get that displacement vector. So add and remember we said when we are adding, we add the i's and the j's alone. So I expect to add the 5, to add the negative 2, the 4 and the 6, and that is your I, and then go to the j and then you'll come up with that answer. Yeah, members, are we good to continue? Okay. Are we good to continue? Okay, 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 okay. Yeah, this one, I think it is for our free time. This is going to be during your free time. So you can just take a screenshot. You try out in 3 vectors. Yes, Tekino?
I was asking,
Mm.
like when we are adding, I thought we are going to add different when we have maybe 5i plus j, then negative 2i plus j, so that we have the last answer is 7i plus 7j.
Your final answer? Come again?
Because I had 5i plus j over, sorry, it is 5i plus j, then plus the negative 2i plus 4j, then 4i plus 2j. Then I had 7i, then plus 7j.
You have added, remember you're going to add this. You add this. I's go alone.
Yeah.
Then have this I here,
Yeah.
or 4i. Then have the 6i.
Yes.
Then you are going to have the
Yes.
j's. J plus 4j
Okay.
plus 2j plus 4j. 5 minus 2, what do you get?
That is 3.
Plus 4
That is 7.
plus 6.
Then that is 13.
I. Then we go 1 plus 4
That is 5.
plus 2
That is 7.
plus 4.
That is 11.
Yeah. I don't know. Have you been able to see where the mistake was?
Okay, thank you, sir.
Okay. Okay. We have said this one, just take a screenshot. Hope you have finished to take a screenshot. Oh, how to do part B? Part B, like they want you to come back. So coming back, we said you just get the negation. Since this is the one that takes you to come back is the negative of this, the change in direction. So you just put negative of 13i plus 11j, which you can get as negative 13i minus 11j. That's when you're coming back. Like the way we did, like you had SC to come back, you get CA. Okay. And here I want you to pay attention to this word. Find the unit displacement vector in the direction SC. So I expect you first obtain your SC. After obtaining SC, go on and find out the unity displacement vector. So you find the unity vector. Okay. We are going to continue. Now, we are going to look at displacement vectors in terms of position vectors. And this is why now we are going to look at that vector geometry. Now, whenever we are looking at displacement vectors in terms of position vectors, yesterday I told that position vectors, it means you dealing with O as the origin, the starting point. And what is very important here is to know that in case this is my vector diagram, let me say this is my vector diagram. And I have, okay, let me draw another one. Okay, in case this is my vector diagram, and this is O. O means that is the origin. Origin is the reference point. Sometimes, depending on the book you are reading, sometimes they may use the word the reference point. So the moment you see reference, it means they are starting from the origin. And this is vector A, and this is vector what? B. This is O to A, and this is O to B. Now, in case I want to obtain A to B, A to B, as long as it is in terms of position vectors, it means that to get our vector A to B, ask yourself at this level, at O level, I know they might have just given you a formula, but you need to know how does it come about. So A to B, like we have said from the previous slides, that A shows where you start from. So it means we start from A and we move towards B. So A, it means that I have A to O. Then from O, I go to B, plus O to B. Now that is by definition. But still from vectors, we know that when you look at the direction we have taken, we have opposed our initial arrow. So please take note that A to O is the same as having negative O to A. In vectors, the moment you interchange the letters like this, then you must put a negative. In case it was, let me say PQ, and you interchange Q to P, then you put a what? A negative. The negative is the one that shows you that now you have changed the direction. So that means that your A to O is the same as negative O to A, then plus O to B. And now, you know, in mathematics, it is always better you meet a positive person before you meet a negative person. Like when you wake up in the morning, always better that the people you meet first are the people who are going to give you positive energy. So that means it's better you start with a positive, which is OB, then minus O to A. And now this is the definition we are going to use for many whenever you find that you are using position vectors. So it is going to be OB minus OA. This second letter minus the first letter. In case it is P to Q in terms of position vectors, then you know it will be OQ minus OP. In case you have any question, ask before we start diving into them. Are we good to go? Let me know through the chat whether now we can continue. Okay, yeah. Okay. Arnold and Pauline, unmute.
Good morning, sir.
Yes, good morning.
Actually, I was just inquiring something very small there. You had written A, right? And then
yes.
you eventually wrote negative or A. I thought you would be writing like negative AO.
Negative?
AO.
Okay, like, let me say Kampala and Ginger. Are you saying Kampala and Ginger?
Yes.
This means that you start from Kampala and you move to Ginger. Is that okay?
Yes.
Now, I can still write the same thing, but here, instead of saying negative, are you seeing? When I start with negative, then I can say Ginger to Kampala. So Kampala to Ginger, it's the same thing like having a negative, because this negative shows you the change of direction.
Yes.
So having A to O, when I change the direction, because here, initially, our arrow was pointing from O towards A. O towards what?
Yes.
A. But when you oppose the direction, then you bring in the what? The negative.
Yes.
But when you bring in the negative, since we are starting from A to O, then we shall say negative A to O.
Yes.
So that's where it comes from.
Yes, sir. Thank you.
Okay. Yes, Pauline?
Teacher, I had the same question.
Okay. Is it fine now?
Yes.
Okay. Okay, now let's start. Yeah, we are going to start with this. Let me hope it's a bit clear. It's a bit clear. And always read the question, because sometimes those position vectors, they may not show you that there is an O, but the question will say that those are position vectors. So let everyone first do part A. So in part A, when you look at it, you notice they have given them to us in terms of ij. I don't know that the question is clear or I need to make it bigger. In case it is small, you can let me know and then I can make it a bit bigger. Okay, people are saying I zoom a bit. Okay, let me zoom a bit. Okay. Okay. Okay, I think now it is clear. Okay. So when they tell us write it in A, B, and C, IJK notation, first write it. first write it the way they want us. And let me hope everyone at least you have an idea on how to write AI. Do not forget, members, those who have this as their first lesson. In column vector, we have X, Y, and Z. In case I'm writing it in IJ notation, I write XI plus YJ plus ZK. That's how I write. So part A is asking you, write each of the vectors A, B, and C in that form. Now, when you look at this, like I told you yesterday, that in textbooks, when you find something bold, it means that that is a vector. But in your book, you may not be able to bold. So for such case, what you do, or you just put that under accent, just put that one, the tilde, to show that you are writing a vector. So we shall have a boy do for us part B, Roman 1, and we have a girl do for us Roman 2, part 2. Okay, Jesse, that's okay. Navish, that's okay. Steve, that's okay. Yeah. Toshiba, yes. Yeah. And now one thing you need to take note is that being a mathematician, when you have a positive and negative, make sure you reduce, make sure you reduce. Okay. Alison, I don't know which answer that is. Okay. We can have someone do for us part B, no problem. Anyone ready? You can raise and do for us one part. Okay. Yes, Ruth.
So for part B, like we are from saying that to get S, like first as girls at the girl is supposed to do part B too. So I'm going to do SC, the vector SC. The vector SC, to get it, since we're being given position vectors, we say vector SC is equal to vector OC minus vector OA, sorry.
Okay.
And OC is -4, 2.
Okay. Ruth, I have a question. When you look at our question from the question, what represents OC? Which letter represents OC?
C.
Then which one represents OA?
A, lowercase letter A.
Okay, continue.
Yes, so now we state them, that is -4. 2, then 24. Then minus vector 2, 5, and -3. So we subtract the two vectors, then we get -6, -3, and 27. Yeah, so that is the vector SC.
Continue.
In IJK form, it's going to be -6i minus 3j, so then plus 27k.
Thank you so much. That's okay. Okay. Which boy is doing for us part Roman 1? Any boy to do for us Roman 1? Okay. Ivan?
Yes. And one we are finding AB, which is OB. which is OB minus OA. And our OB is B. Our OA is A. So we substitute in, that is 2, 5, negative 3 for B.
Is that fine? Continue. Okay, Ivan, I lost you. Okay, so I don't know whether members are getting this answer. 4 minus 5 is negative 1, and 6. I hope that's what we are getting. Okay, members, you let me know whether you're getting that answer. Whether that's the answer we are getting for AB. Okay, Martina says yes, Toshiba yes, Joshua yes, Jojo yes, Innocent, yeah. Okay, yes, Gilbert.
Also, I have one question, like that part. For me, as part the Roman numeral 1 of part B. For me, I've done it in the way that I said to get AB, I will move AO, then plus OB. And same answer. Is it?
Yeah, it is correct. It is very correct.
Okay, thank you.
Okay. Okay, thank you. Then, now I want us to use our mathematical eye. I want you to look at A, B, and C for part C. Describe the relation between the points A, B, and C. Justify your answer. So, I want you to look at the relation we have AB and SC. When you look at them, which kind of relation are you noticing between those? Alice is saying collinearity. Alice, do you want to throw more light?
Okay. Good morning, sir.
Morning.
When you look at the vectors for SC and the vectors for AB, you know the vectors AB and SC have one common point, which is point A, right? So if they have one common point, which is point A, and the vector AB, okay, when you look at its X, Y, and Z components, it's okay. When you look at SC is a scalar multiple of AB, basically, right? Which means that I multiply AB by a particular scalar, in this case 3, and I multiply AB by 3, I get AC, right? And because AB and AC have the same common point or starting point, which is point A, and they run in the same direction based off their vectors, since one is a scalar multiple of the other, it means that the point A, B, and C lie in a straight line. Yeah.
Okay. This is what you have come up with?
Yes.
Okay, perfect. Yeah, so that is very correct, Alice. And I don't know whether other members are noticing that when they ask for the relation between the points, someone can first come and draw something like that that I have A, I have B, and I have C. When you look at that, because here, the beauty with math, sometimes the question may flow from one point to another. When you look at A and B, and then you look at your A and C, at O level, you looked at what we call collinearity. Collinearity has two conditions. One, there is a common point. And when you look at our AB and SC, the common point, like Alice has told us, is A. That is the common point. Number two, you ask yourself, is there something which when I multiply with the other vector, I can get exactly the same vector? That yes. And now that is what we call a scalar multiple. So when you look very well at AB, this is negative 2i and this is negative 6. When you look at it, negative 6 divided by negative 2, you are going to get 3. When you look at the I component, the j component and the j component, negative 3 divided by negative 1, you get 3. When you look at this 27 and the 9, 27 divided by 9, you also get 3. So what does it mean? It means that 3 is a scalar multiple. That means that when you multiply vector AB with 3, you get exactly SC. And now that is the justification they wanted. That the relationship between AB and SC is that SC is equal to 3AB. And therefore, the two vectors are parallel because there is a scalar 3 which when you multiply with vector AB, you get exactly the same point. In other words, A, B, and C lie along the same line. So that's how you can now do your justification. By justification, it means that you have to go on and find out this Fourier to show that there is a scalar, so that, and then in your conclusion, in words, you can say that they lie along the same line, they are collinear. Those are the words you can use when you are describing the kind of relationship. Are there any other relationships? Yes, we are going to look at other relationships. Like whether they intersect, whether they are skew. We shall look at those ones in vectors. But those ones will come mainly when we have lines. But here the common one is going to be to prove whether the vectors are collinear, whether they are lying along the same line. Members, are we good to go? Yes. Okay. Let me know through the chat whether we are good to go. Okay. Okay, members are saying, let's go, let's continue. Okay. I think this is the one we have done. This one, just take a screenshot. It is, oh no, let's do it. It is in the same caliber. Let's quickly do it. And let me hope now have that mathematical eye and check what they have told us. They have asked us. They have asked us the magnitude. We said whenever you find those two bars, it means magnitude. But the first thing you have to find is AB. So first find your AB. After getting AB, we go on and find the magnitude. So let's first do that. Okay, okay. I'm seeing the answers in the chat are very okay. Decimal places, Babi, we said at least 4. Yeah. Anyone finding a challenge with this number? Well, Rita said that we do it. Okay, can we have someone just to give us a brief? Okay, Linda. Gloria?
Yeah, teacher, for the number, we had to calculate the magnitude of AB given the position vectors. So now we had to first find AB, where AB is equal to OB minus OA. Then OB is -3, 4, and 5 minus 2, 3, -1. Then the answer is -5, 1, and 6. Then to find the magnitude, we find the square root of -5 squared plus 1 squared plus 6 squared, which is the square root of 62, which is 7.8740.
Okay. Thank you, Gloria. Yeah. Yes. Those who want, I know you can put the word units, but it is well. So that's how you do it. And let me hope now it is fine to the one who asked. Okay. Okay, now we are going to start on this type of items. Please take note. Now we are starting the vector geometry. We are starting the vector geometry. Yes, yes, yes. So we are going to, okay, let me ask Evans. Yes, you may first ask.
Good morning, sir.
Yes, good morning.
Well, teacher, I came a bit late, so I was inquiring where can I find the recordings of the lesson?
On Holistic E-Learning Platform, YouTube.
Okay, sir.
But we shall share the recording on the group, on the WhatsApp group.
Okay, sir.
Okay, now they have given us this kind of figure, our triangle O to P. Now, always read through the question. Here they have given us the ratio. They are telling us that M is the midpoint of O to P. This is our O to P, and they have given us M as the midpoint. Midpoint means something that divides something into 2 equal parts. So, if I may ask, what would be the ratio O to M, M to P? Put your answer in the chat. What could be that ratio in the chat if it is being divided into 2 equal parts? Hey. Patrick says 1, 1, 1, 1. Very good. 1, 1. That is very okay. So that here we shall have 1, we shall have 1. Whenever they give you midpoint, just know that that is 1, 1. As long as when you add the 2, you get the answer as 2. That is the meaning of midpoint, that you have divided something into 2 equal parts. Now, they have given us O to T as A, T to P as B. So they told us that express OM in terms of A and B. Now, here, it is very important for you to first ask yourself, what is O to M? O to M is this line here. And ask yourself, if I'm to get O to M, it means that I must know what is my O to P. So that is the first thing we have to find. And that's why now I always emphasize you need to know how you are going to move. So when you look at our vector, you are going to notice that in order for us to move from O to P, I'm going to use this direction. I'm going to move O to T. Then from O to T, I'm going to add on T to P plus T to P. And I know very well that from O to T, they have given us vector A. Then plus T to P, they have given us vector B. And this is our O to P. Now, after getting that vector O to P, you ask yourself, how many parts does O to M contribute to the overall parts of O to P? So when you look very well, you note that O to M takes one part of the total parts that make up the line O to P, because the whole line of O to P is made up of two parts. So that means that O to M is going to be one part of the two parts that make up the line O to P. And now that one will equal to 1 out of 2 in brackets A plus vector B. Someone who wants may still write it as 1 out of 2A plus 1 out of 2B. Someone can write it like that. So that is our vector. Kindly let me know whether we are on the same page. Is that fine? O to M. Okay, that is okay. Then the last one is going to be your T to M. Now, still when it goes to TM, it is very important for you to first know how do you reach M from T. So this is T to M. So first join always. For these vector diagrams, feel free to join such that you are not confused. So I'll join T to M like this. Now, after joining, we say the first letter shows you the starting point, and then the second one shows you the starting. It means you are going to start making your movements from T. So I can say I'm going to move from T to O. So I say I'll move T to O. Then from O, since I'm going to M, I'll go to M. O to M. Alternatively, it is also okay for you to move from T to P, then from P to M. That one is also very okay. So T to O, since we have gone opposing the direction, at first we had A, but since we are going T to O, then this one is going to become negative. So allow me to write here that this is going to be negative A plus O to M, which we have already obtained as a half of A plus a half of B. And therefore, we are going to have negative A plus a half of A. We end up with 1 out of 2. That is like having negative 1 plus a half, which gives us negative a half of A, then plus a half of B. In case you want to write it in a more simpler form, you can even factorize out the half and say this is going to be 1 out of 2 into negative A plus the B. If you want to write it in a much beautiful way, it is also okay. You can say this is the same as a half. Start with the positive of B minus A. So that is how you deal with such a part. In case we have some questions, feel free to ask. Feel free to ask. You let me know which part. Now this part TO, like I told that TO is the same as negative O to T. That is the meaning. Okay, yes, Martina.
Yeah, could we please do it the other way of TP and then PM?
You take us through, don't go. You want us to do it? TM to take which route?
We're taking TP
TP
plus PM.
PM. Good.
Yeah.
What is your T to P?
B.
It is B. Do you have PM?
I would say it's a. Can I say it's a half A plus B as well?
Now, for that one, I want you to look at the direction. When you are moving from P to M, are you seeing P to M?
Yeah.
It will mean that P to M is one part of the two parts. But since you are starting from P, now your line is going to be facing PO. I don't know that you are getting it.
Yes, teacher.
So for it will be P O.
Oh. So will it be a half A minus B?
A half,
A minus B.
A minus B. What is P to O now? Because here the question we have OP. So what is PO? First give us what is vector PO.
To be negative OP. Which will
Negative
be
OP. Good.
which will be negative A minus B.
Minus B. So that's what we are going to have here. Negative A minus B. We continue?
Yeah, people can continue like in their books.
Okay. Yeah. So here you'll have negative A and you have negative B. So when you try to work it out, you are going to come up with the same answer here. The only trick here you need to know is that since you are moving from P towards O, here you cannot use the vector OP the way it is. You have to interchange. Yes, Evan, and then Tekino.
Thank you, sir. My question is that, shall we are taking the route to TM, right?
Yes.
So if we are to move in one direction of the vector diagram, we can still reach the vector direction. For example, you've moved from TO to OM. So teacher, why are you making it as if that TM, in order to get to read that direction vector TM, we have to add both of the either sides, yet there are different routes to reach there?
Oh, what I'm saying, okay, first keep on. This is one way and this is another way. It's like you moving Kampala, let me say this is Kampala, which part? I don't know. Like, let me say this is Kampala, Mukono, and Jinja. So if you want to move from Kampala to Jinja, you can decide to move from Kampala to Mukono, Mukono to Jinja. Another person can say, I'm going to pass from Kampala, I go to Gayaza, I go to Jinja. So to reach from T to M, to reach where M is, you can either use this route or use the other route. But for whatever route you use, you'll get there and you get the same answer.
Okay, sir. Now, if that's the case, what if they have given us value to substitute for the B and A? So when the answer change, because I thought if we want to get the same answer or different answer, we consider them separately. But then putting a plus means that they are connected.
Oh, like this plus here?
Yeah.
Now, when we talk about vector addition,
Yes.
Vector addition, vector addition means that let me first remove this. Okay, I'm going to clean my screen to be able to explain to her some concept here. So let more people finish to write. Yeah, now, when it comes to vector addition, let me say I have 2i plus 3j. Are you seeing that? Okay, let me first, I don't know why this thing is not writing the way I want. Just a minute. I'm putting back. Hope you are still on.
Yes.
Let me say I have 2i plus 3j. And I have 2i plus 2j. When I tell you this is vector A and this is vector B, what answer will you give me for A plus B?
4 and 5.
And 5. Now, in geometric way, how does it come from? This is 0, 1, 2, 3, 4, 5. This is 1, 2, 3. This is 4. Now, A plus B means that where A stops, add on the next one. That is the meaning. So A is going to be 2 units along the x-axis. So I'll move from 0, I'll move 1, 2. When I reach 2, I move 3 steps upwards. So I'll move 1, 2, 3. So this is where the vector is. I'll draw it like that. Now, when they say add on B, what does it mean? It means that from B, from where we have ended, we add on B. So B is 2 steps to the right. So I'll move 1, 2. When I reach here, I move in the Z direction, 2 steps. So this is 4, this is 5, this is 6. So I'll move up 2 steps. So I'll move 1 and 2. So it's going to be here. So it's going to be here like this. And this is our vector B. This is our vector A. Now, when I tell you A plus B means this direct route, this direct route from where you've started from up to where you have ended here. This is what we call our vector A plus B. So addition, when you see that addition, means that you have where you have ended is where you start from. So that's why we add. So in vectors, we don't jump. I don't know that you're getting the concept. That's why here you answer 4, 5. When you check out this vector at this point, down here, you are going to have 4. This side, you'll have the 5. So that's where you have. So that 4, 5 shows you the final point where you are. That if you are to move directly, you would have moved 4 steps and 5 steps. That is the meaning.
Yeah, thank you, sir. I've got you.
Okay. Okay. Members, are we on the same page? Because our time is up. Yes, Joyce, they have. Yes, Jordan, that is okay. Okay, I think we are good. So why don't I give you at least one number that you are going to try out? I give you this one. Which one should I give you? Okay, let me give you this one. So take a screenshot. We shall try out this one. So take a screenshot. We shall try out this. Okay, hope we have taken a screenshot. So, members, we shall start from there tomorrow. But I'm going to send it in the group. Feel free also to try out other numbers. And then when we come back tomorrow, we shall also look at how we prove the collinearity, and then we shall start building up from there. Otherwise, thank you so much for attending. Let's meet again tomorrow, same time at 5. Yes. Have a good day, everyone. Bye-bye. Oh, someone wants the group. Okay, let me first share that link for the group.